A space rock 6 miles wide targets the ocean off New York City. It closes at 90 times the speed of sound. It buzzes Washington. New York City is vaporized. A crater stretches from Newark, New Jersey to New Haven, Connecticut, over 100 miles wide. As the shockwave blasts outwards, the rest of America, the rest of the world, stares doomsday in the face. Such a catastrophe has happened before, and it'll happen again. The last one destroyed the dinosaurs. The next one, unless we protect our planet, will annihilate us.
Everything we can see here would just disappear, along with some miles of depths of rock underneath. Lumps of rock the size of these skyscrapers would start raining down upon Washington 30 or 40 seconds later. Chicago would get similar sized rocks 2 or 3 minutes after that. Los Angeles and San Francisco another 5 minutes later. It truly would be calamitous for the whole of North America, indeed the whole of the world.
What the shockwave doesn't get, the Holocaust does. Material blasted into space rains back as meteors, igniting fires. Smoke, toxic fumes, and the flicker of falling fireballs. Our population centers burn. Every city, every village consumed. Worse still, our food is gone. Every blade of grass, every bushel of corn devoured. Within hours of the impact, the entire globe is ablaze.
There would be no hiding place from a cataclysm such as this. However, the after effects of such an impact would last for thousands of years. So we're certainly not looking at civilization regrowing itself in a matter of months or years or even decades. We're looking at very long-term effects here.
In the short term, it's cosmic winter. Debris from the impact and soot from the fires shroud the planet. It's as dark as night.
There would be enclaves, certainly, of people in protected environments who would survive the blast and the 6 months of darkness and the wildfires. But what would they come out to after this? A devastated world, a devastated planet.
"65 million years ago, there were just 3 minutes to impact as a projectile 6 miles across closed with the Caribbean at 60,000 miles an hour. The smack equaled 75 million megatons of TNT. Without sunlight or food, the dinosaurs that survived the blast perished in the cosmic winter that ensued. When the skies finally cleared, the great reptiles had gone, along with 67% of all species on Earth. Our New York impactor is a replica of the projectile that dispatched the dinosaurs. The aftermath is the same. Around the world, thousands of volcanoes would burst from fault lines, further fueling the cosmic winter.
It would be so dark, you wouldn't be able to see your hand in front of your face. So that means no photosynthesis, no plant activity, no food, It means cold climate because you lose the sunlight. It means really severe climate conditions. I mean, what more do you need to have an ecological disaster that would kill off most of the species on the planet?
As cosmic winter yields to barren spring, there are winners and losers.
What wouldn't survive? Large animals, animals that need a lot of fresh food, that are in the open, exposed, animals with small breeding populations. We'd certainly lose all the large mammal fauna of the world.
And we lose the human race. Those of us who survive the impact expire in the cold and famine that follow. Like the dinosaurs, we give way to a more humble form of life.
It's like the meek inheriting the earth. The small organisms, the hardy organisms, the one that produce a lot of offspring, very prolific, like insects, like cockroaches.
"65 million years ago, creatures like this gave rise to the mammals and humankind, thanks to an impact.
This is the most exciting thing happening in the geological sciences. It's really a revolution in our way of looking at the Earth. Because impacts for a long time, in fact even today, are being ignored or played down as their possible role in Earth history. And what we're seeing is, from the astronomy, from the geology, that impacts have been very important in Earth history and the history of life, and they will continue to be in the future.
With this new idea, called punctuated evolution, scientists are seeing the world in a new light, beautifully serene, but awaiting always a catastrophe from space.
The Earth is a tranquil place, but it's very sensitively balanced, as we have come to realize. It doesn't take much to get the environment out of kilter. So even a relatively small impact, something that would be far too small to affect the orbit or the axis of the rotation of the Earth, can really mess up the environment and lead to mass extinctions.
A new version of Earth history is emerging, one that sees occasional catastrophe as essential to development. A bolt from the blue brings millions of years of gradual evolution to a halt. The old order exits, a new one enters, the process that gave human life its chance. But equally, it can snuff us out. After an impact, imagine the Galapagos Islands, where Charles Darwin was inspired to propose his theory of evolution. These islands would be virgin land awaiting the replacement of humankind, the reordering of life.
This scientific insight is comparable in importance with the insight of Darwin, who, quite correctly, emphasized the possibility, the probability, the existence of the slow evolution. We now, I think, clearly understand that there are periods of slow evolution separated by occasional violent effects. To get the relation between the two will change our whole outlook on the history of all living beings on the Earth.
But as we await the big one, smaller missiles continually tease our planet. They threaten millions of us.
The last time it happened was 5 months after I was born.
June the 30th, 1908, Ground Zero. When expeditions reached this place, it was a scene from the apocalypse. 800 square miles of forest flattened by a missile that exploded 5 miles up in the atmosphere. The blast was at Tunguska, Siberia. It was equal to 1,000 Hiroshima bombs. As far as we know, no one was killed, so remote is the region.
If the same thing had happened over New York City, it would have been the major disaster.
The cosmic fragment that caused the air blast was just 200 feet wide. Far up the Amazon, where Brazil meets Colombia and Peru, an old fisherman leads researchers to the spot where he watched a fireball plunge to Earth in 1930. Raimundo Clemente da Silva is 87 now, the only known surviving eyewitness. He recalls explosions and fire. The river trembled. A missionary informed the Vatican of hundreds of terrifying accounts from traumatized people. Ash rained for half a day. Raimundo was making for this very beach to seek turtle eggs. His recollection is uncontaminated by written reports, for Raimundo cannot read. He tells how the sky brightened and a fireball like a brilliant blue planet streaked earthwards. A thunderclap followed. The missile came in at an angle that took it beneath the moon. Undoubtedly, something extraterrestrial hit the rainforest that day. Not far from the old man's beach, a Brazilian astronomer believes he's identified a crater-like structure. And these traces from a seismic station in Bolivia show a mysterious disturbance coinciding with the date of the sightings, August the 13th, 1930. November the 21st, 1995. In the small hours of the morning, there was a blast over Peterson Air Force Base, Colorado. Doors shook, windows rattled at this, the headquarters of the US military space program. Inside, personnel thought they were under attack. Outside, the locals knew it was a rock from space.
It was about this size.
While I was lying there, I heard this tremendous boom that shook the windows.
Suddenly, the sky had lit up as though the sun came out. I didn't have a clue as to what it was that I was seeing.
Scary.
I thought I saw a comet.
Remarkably, a security camera captured the explosion.
The energy released at that time was probably like a small Hiroshima.
Roughly once a week, a space rock several yards across hits Earth's upper atmosphere. These are impacts recorded by spy satellites. As the projectiles explode, they look uncannily like nuclear blasts. It worries the military. This impact over the Pacific during the Gulf War could have been mistaken for the introduction of nuclear weapons in the Middle East, had Earth been rotated another 6 hours. But for NASA's David Morrison, the real concern is the big one.
We know of nobody who's been killed by being hit by a comet or asteroid. The events are very rare, but when they happen, as many as 1 billion people could die at one time.
Morrison is director of space at the Ames Research Center in California. Earth, he says, has suffered a whole series of gigantic impacts, not just the one that slew the dinosaurs. There'll be another, and he's worked out our chances.
The odds of dying as a result of an impact are about 1 in 1 million per year. That's just about the same as the odds of dying in one round-trip commercial air flight, or the same as the odds of dying in one fairly long automobile trip. The chances of being killed from a smaller impact, that is from something the size of a house or a building, is about 1 in 100 million, much less than the risk due to a global catastrophe.
What worries Morrison is that we're doing too little to protect ourselves from the one great natural hazard that could obliterate the human race. Yet we have the power to meet the threat from space, to keep the lights of civilization burning. Morrison is determined we use it.
Sir Isaac Newton tells us that the acceleration of a ball
A space rock 1,000 feet wide hits the ocean, and a wall of water roars towards Australia. It's the nightmare that threatens the entire Pacific Rim.
If a missile like that was to hit the Pacific, it would generate a tsunami, a tidal wave, which would wipe out the whole of Sydney. The bridge, the Opera House, the whole of the populated region, right the way up to the Blue Mountains, 30 miles inland.
The Pacific Rim boasts some of the most expensive property on Earth. In terms of tsunami hazard, it's the worst possible insurance risk. Tokyo, population 30 million, the biggest and busiest metropolis of them all. In a nation so plagued by earthquakes, it's no coincidence that the Japanese give us the word and teach us to fear tsunami. Ishigaki off the south coast of Japan. In 1771, a tsunami sent 17,000 islanders to a watery grave. The Buddha at Kamakura. It sits alone 400 feet above sea level in the hills near Tokyo. Once it sheltered in an ancient temple, until in 1495 a tsunami swept away everything except the great statue. As it lives with earthquakes, Japan takes earthquake-induced tsunamis in its stride. But from high in the Tokyo Tower, Shin Yabushida, professor of applied mathematics at Kyoto University, counts the cost of a tsunami triggered from space. He's troubled. Tokyo goes about its business oblivious. Should even a modest asteroid hit the Pacific, a monumental tsunami would wipe out this economic nerve center.
There is 1% possibility of such an asteroid hitting somewhere in the Pacific next century.
And he knows the price.
I would say that the damage would be $1,000 billion. And this, I think, is a rather modest estimate. As the wave advances, it will destroy these buildings, and perhaps some of the very well-built buildings may stand the waves, but those things which are in the buildings, they will be destroyed.
The systems, the computers, the data that drive the world's corporate giants washed away. The consequences for Japan and the global economy, says Yabushida, are incalculable, quite apart from a tragic loss of life.
We should be worried about an asteroid with a diameter 200 meters, which is, say, 3 times as big as the building you see over there. That kind of an asteroid will hit the Earth once in every 4,000 years or so. Now, the Pacific Ocean occupies about 30% of the surface of the Earth. So it means that such an asteroid would hit somewhere in the Pacific once in every 10,000 years. And I think the government should take this problem very seriously.
This is the 1% chance feared by Yabushida. As a projectile hits the Pacific, a distant ship sees the impact, but quickly most traces are swallowed by the ocean. Sometime later, the vessel rides out the shockwave as it sweeps by at 500 miles an hour. But beneath the surface, that ripple is the tip of a gigantic pressure pulse stretching to the ocean bed. This is the invisible power of an evolving tsunami, fast and silent. When it meets the continental shelf, the pulse is forced upward to create a giant wave of death. Imagine the last plane fleeing Tokyo as the tsunami breaks. tsunamis. Wreakers of havoc. This century alone, earthquake-induced tsunamis have claimed 51,000 lives. To seek the asteroids and comets that threaten us, we must leave Earth and the inner planets and travel towards the debris of the solar system. Outwards, past the farthest planets, is the Kuiper Belt, where an icy band of comets lurk. Far beyond is the Oort cloud, where billions of comets form a sphere around the solar system. Normally they lead quiet lives, but just a nudge can send them hurtling towards the planets.
To get a comet to leave the Oort cloud and say goodbye to all its sister comets and start on a new path that'll take it closer to the Earth, you don't need a whole lot. The equivalent of just that.
That nudge is caused by the gravitational push and pull of the Sun and its neighboring stars. Once dislodged from the Oort cloud, comets become wildcards. They swing through the planets on crazy elliptical trajectories that take them round the Sun. We know of about 1,000 comets, but it's the one in the billions we don't know about that could knock us for 6. While comets are like dusty snowballs, asteroids are rocks. They swarm in a belt between Mars and Jupiter. They jostle and bump under the spell of Jupiter's gravity. Some tumble from the belt and menace our planet. Earth-crossers. This one, Tutatis, will pass within 1 million miles of us in 2004, an astronomical near miss.
Think of yourself on an interstate highway, and there are cross streets. No traffic lights, no stop signs on these cross streets. And nobody's going to stop. The Earth is barreling down the interstate highway. If these Earth-crossing asteroids happen to cross while the Earth is there, they'll hit.
Australia, paradise for those who hunt evidence of rocks that fall from space. Together with David Levy, Eugene and Carolyn Shoemaker have done more to alert us to the threat from asteroids and comets than any other astronomers. For 3 months a year, the Outback is their laboratory. They made their name in 1994 as the fragments of a fractured comet slammed into the giant planet Jupiter. Thanks to the Shoemakers and colleague David Levy, proof positive that rocks rain from the heavens. Before it tore apart, the comet was the size of Ayers Rock. They'd discovered Comet Shoemaker-Levy 9.
Of course, you don't have to go as far as Jupiter to see the effects of comet and asteroid impact. Look at the moon.
Our satellite is pocked with celestial buckshot. Through more than 4 billion years, it's been smacked with the debris of the solar system. Each crater testament to an impact. Comets and asteroids as big as mountains. Fragments as small as a bus. A blitz of ice and rock and iron. So why doesn't planet Earth show similar scars? Where are the blemishes? They're there, if you know where to look. The Outback is the place. With its sparse vegetation and geological stability, Australia retains more evidence of impacts than anywhere else on Earth. On each research trip, the Shoemakers cover 10,000 miles, sleeping beneath the stars, finding impact sites. They've 24 craters to their name.
I'm standing here on the main crater at Henbury, Australia. It's part of a complex of big craters clustered together. There are actually 9 other craters as part of the strewn field here that was formed by a meteorite coming in from over there breaking up before it hit the ground. Now, in slow motion, imagine this object coming in and about perhaps 10 miles uprange. The pressure on the meteorite is getting so great and it's being crushed by its own inertia against the shock wave in the atmosphere that it's breaking apart. And the smaller pieces then start to lag behind, but it's still coming in very fast. At the moment that the first fragment hits, the meteorite penetrates into the ground like a bullet as the crater forms. And so the meteorite is sheared along the wall of this ever-growing cavity, and in fact the rocks are melted by friction, and some of the meteorite is melted and mixed with it. And we still find that in pieces of glass, of the molten rock, strewn out mostly downrange. Meantime, the craters were forming bang, 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 right close to each other, and the main crater is actually a double crater formed by two objects hitting fairly close together, and so the two craters actually merged.
Shoemaker is a legend. Against the tide, it was he who convinced astronomers that the craters of the moon were formed by impacts and not by volcanic action. And today he reports a new terrestrial finding.
We have good news from our side. It's a very remote site in Western Australia, but by golly, it's an impact structure. It's about 18 kilometers across. Maybe some imaging from space will help to bring this thing out. It was completely missed in the reconnaissance geologic mapping.
The Shoemakers believe they found an ancient crater in the little sandy desert of Western Australia. They've asked a shuttle astronaut to help. He's looking for a 12-mile crater, so eroded and sand-filled that only magnetic equipment and the Shoemakers' field examination suggest it's there at all. The shuttle picture shows a barely discernible structure, but to the expert eye, it's a crater. There's no mistaking this one, Australia's greatest crater, Goss's Bluff, 14 miles wide and 140 million years old. This is Tiny Wolf Creek, one of the youngest and best preserved craters in the outback. It wasn't the first, says Shoemaker, and it won't be the last. The Henbury craters were formed just 3,500 years ago. By contrast, Earth was formed 4.5 billion years earlier. Strip away our atmosphere, our vegetation, our oceans, and all geological movement, and this would be our world. A planet with 20 times more craters than the Moon. But how do we detect these missiles that constantly assail us? Kitt Peak, Arizona. Tom Gerrels prepares for his nightly vigil. As the sun slips away, so begins the patrol of his Spacewatch telescope. Run on a shoestring and using a 70-year-old instrument, Gerrels and his telescope may be all that stand between us and doomsday. Tonight, he's jubilant.
I found not only one fast-moving object, but
he's found two new objects close to Earth. But that's his task, to hunt and track the hundreds of projectiles that potentially threaten our planet. Space rocks bigger than 2/3 of a mile.
It is an intolerable uncertainty that right now there are some 1,700 or so larger than 1 kilometer in diameter, and we don't know whether any one of these will be hitting the Earth. That requires the greatest urgency to do what we're doing right now with the systems that we have and the systems that are coming online.
Gerrels only recently appreciated the scale of the nightmare that may be heading our way. The impact of an asteroid just 2/3 of a mile wide would have the destructive power of 1 million Hiroshima bombs.
One Hiroshima destroyed a city. 1 million times the energy used at Hiroshima. That reality, that acceptance of it and understanding the horror of this event, that occurred to me only a few years ago.
On average, Gerrels and his team find 2 Earth-crossing asteroids a month, the tip of a cosmic iceberg. America has 3 other asteroid detection projects, like this one on Maui in Hawaii. France has 1. Together, they're finding about 70 new Earth-crossing asteroids a year, objects that, if they hit us, are big enough to radically upset our climate. But our telescopes need to be finding 500 new Earth-crossers a year. That's the target if we're not to be taken unawares by an impactor. There are simply too few professional detectors. Amateurs remain our unpaid sentinels. Were a new comet heading for Earth, it would most likely be discovered by an amateur.
Amateurs can find comets generally when they're near the sun, so that if they did discover a comet on a collision course, we wouldn't have very much notice. We would like to have the discovery made a lot earlier, when it's further away, it's fainter, and there the amateur would not be able to do it anyway. So this is where the professionals should really be doing their job.
Los Alamos, New Mexico, birthplace of the atomic bomb. Here, in 1992, gathered almost 100 of the world's top military scientists and planetary astronomers. In secret conclave, they discussed how to protect Earth against annihilation from space. Nuclear physicist Greg Canavan, who chaired the conference, recalls passionate debate.
We know that the comets and asteroids are out there. We know that they strike the Earth from time to time.
What you don't know is whether that impact will be in 60
The scientists considered 2 main issues: how to locate and track potential impactors using technology once used to find killer satellites, and once found, how to intercept the impactors.
Stony, are they metallic, or are they like comets?
Pulverization.
From blasting asteroids with nuclear warheads to just thinking good thoughts, every idea was encouraged.
Do a few calculations to Congress and say, would you give us enough money just to look out there and see what's there?
Among the participants was the father of the hydrogen bomb, Edward Teller. Surprisingly, he doesn't favor the nuclear option. What then could we use in the face of a 6-mile projectile heading for Earth?
I think we have nothing that we have studied, understand, and can responsibly employ. We have lots of ways to defend ourselves against smaller impacts, which are 1,000 times more likely.
The quest of Eugene Shoemaker continues. Geologist and comet hunter, Shoemaker is preoccupied with another concern: planetary defense, the need to convince governments that the threat of impacts from space is real and that money must be spent searching the skies. Shoemaker heads for Uluru, the mysterious monolith of the outback, better known as Ayers Rock. In Aboriginal legend, these geological formations represent battles fought by the animal people who first walked the earth. Uluru sits at the heart of Dreamtime, the mythical universe where Earth is the realm of the living, space the realm of the dead.
It's big, 1.5 miles across, 6 miles around, and over 1,000 feet high. However, it's not made of the same things that asteroids and comets are made of. It's made of sandstone, the kind of rock we find on Earth. But it does give us an idea of the scale of our problem.
Uluru is about the size of the comet discovered by the Shoemakers and David Levy before it fragmented and hit Jupiter in 1994. Unlike comet Shoemaker-Levy 9, Uluru diverts from Jupiter for a swing through the planets. Some 1,000 comets are known to orbit within the solar system, and several hundred asteroids are logged as Earth crossers. None currently threatens Earth, but millions, maybe billions, remain undetected. And if one hits, it won't be a soft landing.
If an object that size hit the Earth, you wouldn't see a rock standing there. You'd see a crater 20 miles across.
The Shoemaker-Levy Jupiter hits briefly impact political thinking. Within a month, Congress orders NASA to find and track every Earth crosser. Today it's much more, but initially just $1 million was allocated to hunt potential impactors.
$1 million out of the NASA budget is totally in the noise. It's a very tiny amount. And some of us think that it would be appropriate to go at a little higher level. Say about $3 or $4 million a year would get us there sooner.
To push cosmic surveillance, Shoemaker co-proposed Space Guard, an alliance of observatories, one in Australia.
Space Guard is basically a United States effort, but a group of us have gotten together and formed the Space Guard Foundation, that's headquarters in Rome, with the idea of encouraging worldwide participation.
No sooner had the Australian telescope come on stream than its surveillance funding was cancelled. Pleas to the British and Australian governments who operate the telescope went unheeded, despite the eminence of one signatory. Duncan Steele ran Space Guard Australia. He now has no telescope and no job. The skies of the southern hemisphere go unpatrolled for killer projectiles. Steele says the cost of skywatching is minimal, set against the potential catastrophe.
Now, if you do the sums for the United States, the annual expectancy of loss in terms of doing something in an actuarial basis is around about $1 billion per year. Nevertheless, the amount which needs to be spent in order to tackle the problem is much, much less than that. In fact, around about 1/10 of that. And so it really doesn't make any economic sense not to carry out this sort of program to actually track all of these objects and determine whether there is one which is due to hit us soon.
In principle, we could go and find all of the bullets that would be hazardous to humanity as a whole. That could be done. It's a doable job, and with appropriate level of effort, it could be done in 10 or 20 years.
The total effort that we, the citizens of planet Earth, are putting into scanning the sky for potentially dangerous comets and asteroids is less than the staffing of one McDonald's restaurant. A handful of people.
A handful of sentinels to watch skies buzzing with eccentric comets and Earth-crossing asteroids. The work has far to go. For every projectile plotted here, 20 or more are yet to be discovered, each one a possible doomsday.
Now suppose an object like that really is headed for collision with the Earth. What do we do about it?
Rule number 1, know your enemy. To that end, in 1996, NASA launches NEAR, the Near-Earth Asteroid Rendezvous, an encounter with a space rock. Harnessing the slingshot effect of Earth's gravity, NEAR is on a 4-year voyage to intercept Eros, an elongated asteroid measuring 21 miles by 8, nearly 4 times the size of the projectile thought to have killed the dinosaurs. NEAR is packed with sensors. It flies alongside Eros, measuring density, mapping topography, intelligence vital for the night we spy a mountain heading for Earth.
There is a simple point which I am trying to hammer in. Solve your small problems. The big problems will then turn out to be not so big.
So, armed with the facts, it's time to choose weapons. In New Mexico, the preference is for mirrors. Here at Sandia National Laboratories, Star Wars technology was developed to destroy incoming nuclear missiles. Now the Cold War is over, can these same technologies refocus on a missile from space? A parabolic mirror the size of Wembley Stadium. The idea is to concentrate reflected sunlight on an Earth-threatening projectile and scorch it off course. There are advocates of powerful laser beams. And of giant pods that approach an enemy asteroid and attach themselves to its surface. Once secure, they release super sails that catch the solar wind and tow the intruder away. Another scheme dispatches a small rocket, a celestial outboard motor. It shunts the object to a safer course. Tony Zuppero rejected these schemes at the Los Alamos brainstorm on planetary defense. Another that missed the target was the mass driver. It moves an impactor by bailing material from the projectile's surface.
We needed these things that were going to scoop and throw. A bucket per second, full, at faster than the speed of sound, going for a year without breaking. Nobody there to fix it. This is crazy.
Zuppero is a ballistics physicist, but his own scheme of deflecting an impactor sounds crazier still.
The way I do it is to hit it with a ball of dust. Now it turns out if I can hit it with a ball of dust about the size of a football field, then this comet thing will get nudged out of the way, and all of us will watch the thing going by from Earth, and it will be scary because we will certainly all see it, but it will miss.
Zuppero takes a generator from a nuclear submarine and attaches it to a lightweight steam rocket. This he launches towards a benign comet to pick up fuel and ammunition. Comets have water ice and dust in abundance. One bladder fills with water, the fuel, the other with dust, the ammunition.
That steam rocket will push 1 million tons of dust into an orbit that intersects the bad thing.
The bladder of dust is released into the path of an Earth-threatening missile. Speeding in at 40 miles a second, the intruder is disrupted and diverted.
Buzz Aldrin, the second guy on the moon, he and I talk about this, and he says this is fanciful. It's fanciful because it won't be there in time for Buzz Aldrin to get on the rocket, but it's science fiction to those fourth graders I talked to.
But supposing there's no time, we'll be hit within weeks. The nuclear option? Crude, simple, a last resort. A direct strike, and let's hope for the best.
The nuclear explosive is the only thing we have, and probably will be the only thing we have for perhaps 20 or 30 years.
The alternative to pulverization is a standoff explosion. The nuclear warhead detonates before it hits the object and blasts it off course.
Now the bombs will work just fine, except I'm scared. Okay, I mean, I don't like the idea of launching half as many bombs as we had in the Cold War all at once from somebody's launch site. I hope it's nowhere near me.
The possibility of nuclear explosives being lifted off by rockets, it makes my skin crawl, but that's what we have.
The greatest threat to the survival of humanity comes from impacts, at least the greatest threat we know of. On the scale of hundreds of millions of years, we must learn to defend ourselves from these impacts. And there are really two ways to go about it. One is to have a defense system that could shoot them down before they hit the Earth. And the other is to develop independent colonies of humans on Mars, for instance, so that if something terrible happened to the Earth, our civilization would survive on Mars and could backpopulate the Earth again.
In Martian biospheres, geneticists husband the life forms of planet Earth. After the apocalypse, they return to our barren world with eggs and seeds, and the precious stock of humankind. Comet Hyakutake in 1996, a reminder of our vulnerability. 2 miles wide, it swept in with only 2 months' notice. Hyakutake missed Earth by just 10 million miles. (1997) and Comet Hale-Bopp. This one has a nucleus 25 miles wide, but it keeps its distance. There could have been another story.
I moved Hale-Bopp's orbit around, just changed one angle, it's fairly easy to do, and put a hypothetical Hale-Bopp on an impact trajectory with the Earth.
It takes the slightest nudge. Using software that predicted the Shoemaker-Levy 9 impacts, CHODIS calculates the time and place of Hale-Bopp's collision with Earth, but with just 6 months' notice.
So, our hypothetical Hale-Bopp case would impact the Earth 1997, April the 24th, 5:35 in the afternoon, the latitude 48 degrees north, longitude 148 degrees east, somewhere in the Pacific north of Japan.
Tom Gerrels and the tiny band who keep watch. Can they give us the time we need? And even if they can, what could we do against a rock with our name on it? NASA reckons 2,000 Earth-crossing asteroids may pose a threat to us. We've identified only 8% of them, and that excludes comets newly arrived from the Oort cloud.
If we should have only a year or 18 months warning on a 10-mile comet headed for the Earth, something that could produce a mass extinction, we do not have any idea how we could avoid that. That is still the nightmare scenario.
Extinction. The reign of humankind is over. But as Earth recovers and breathes again, who would notice we'd been here at all?
Prayers and Prophecies next, preached by people who put their faith in divine destruction, a tour of cults and religious groups. Welcome to Armageddon.
Someone by night, someone by day, nothing could change you, set and sure away. There is the sun and moon facing their own sweet tune. Watch them when dawn is just met